Okay, so we're going to talk about sequences today, but let's start off by just defining both and comparing them, and because this first initial idea is crucial. If you without this firmly in place, you'll just be lost. So a sequence is an ordered list of numbers. Okay, a series is here's the key. A series is the sum of all numbers in a given sequence. Okay, so again, sequence is the list. Sequence is the list. You're listing first number, second number, third number, fourth number. Then the series for a given sequence is when you add them all up. You add them all up and you sum them together. So sequences. So that's just a... You get in the middle of these hard problems and you're memorizing these rules and these formulas, and then you don't even remember what a series or a sequence is. You can never forget that. Okay? Okay, so here's the sequence. Okay, what's the next value of the sequence?
Don't they have to be in brackets?
13. No, you can put it in brackets if you want, but it's just a list. It's an ordered list. If it's not in brackets, it doesn't make it not a sequence.
Oh, okay.
Yeah. What's the next in the sequence? Do you know that for sure?
No.
Could it be 1? 1, 3, 5, 7, 9, 11. 1, 3, 5, 7, 9, 11. 1, 3, 5, 7. So all evidence points to 13. But it's not guaranteed, okay? Unless you have a rule, right? So we'll talk about that in a second. But just given this, yeah, we're betting on 13, but not a guarantee. Okay, so if we wanted to write this sequence as a sub n, okay, so what is A3? Easy question. What's A3? 5, right? Okay, and 11 is A what?
That's
A6. It's the sixth term of the sequence. 11 is the sixth term of the sequence, so it's A6. 5 is the third term of the sequence, so it's A3. Okay? So? Can you find a formula that gives AN? AN equals what? And that what is going to be based on N. So something, an expression with N's in it. Can you do it? Everyone work on it by yourself. So this is kind of like a puzzle, right? It's kind of like a puzzle. What expression, formula that has N's in it, if you plugged N in, would give you the N term of the sequence. So if you plugged in 5, you would get, what? 9. If you plugged in 2, you would get 3. I think it's easier to figure out if you look at the big numbers, not the small numbers. So if you look at 4, 5, and 6 for N, I think it's easier to figure out what A, N, and B mean those. 4 gives 7, 5 gives 9, 6 gives 11. So what does N give? Travis, you got it?
Like the equation?
Yeah, the formula, the expression.
2n minus 1.
He wants 2n minus 1.
Yeah.
Does it work?
Yeah.
Yeah, because the nth term is always 1 less than double. So double 6 is 12, double 5 is 10, double 4 is 8. It's always 1 less. Okay, so now if I say this sequence is sequence 2n minus 1, then what's the next term of the sequence? 1, 3, 5, 7, 9, 11. Guaranteed now, right? Based on the formula 2n minus 1. 13, right? So with the formula, then whether you have it written down or not, every member of the list is determined. Okay, questions so far? So let's look at some other formulas. All right, and there's nothing magical about A. It's just the most common first choice. So you could have C. Or B. Doesn't matter. Okay, so why don't you find the first 3 or 4 terms of C, N, and Bn. Can you do it without your calculator? that?
You say the final term or
The final term. What's the final term? What is the final term? Does that make sense? Final term?
No, the first one.
Yeah, no, so just go on. So there is no final term, right? Because n just keeps getting bigger and bigger. So there's no final term. So I'm just asking for the first couple terms. Say three. First three terms. Were you able to do this one? You know what tangent of pi over 4 is? Without your calculator? Should. Where's the angle pi over 4 and what's the meaning of tangent? Pi over 4 is straight up, 1/4 of a circle. Quarter, that's what I mean, quarter of a circle. Half of that. There's pi over 4. And what's the meaning of tangent? Anyone know the meaning of tangent? That's not the meaning. So it's like the slope or rate of change, slope of that line, right? Slope. What would it be? No, what's the slope of a 45-degree line?
1.
Thank you. Okay, and then now we're getting, this is our sequence for what? 1, 3, 5, 7. So 3 pi over 4. Where's that? What will its slope be? 3 pi over 4 is over here. And what's its slope?
-1.
Jasmine knows. Does anybody else know? All right, next one, 5. 5 pi over 4. So when n is 3, you get 5 pi over 4. Slope? That's down here. That's 1 again. And we get 7 pi over 4, which is here. So what happens to this? So these are both called alternating sequences because they alternate sign, positive, negative, positive, negative. And you see there's more than one way to achieve that, right? You can have -1 to the n, get this alternating effect to the terms. Or you can do the trig function, that can give an alternating effect. Because we know trig functions are cyclic, right? They repeat. And this goes on and on and on. So the idea is that n, you just keep going on and on and on, and the sequence has an infinite number of terms. Okay? So a sequence is convergent so in easy basic terms, it's convergent if the sequence always gets closer and closer to a certain value. And what mathematical principle is that? So with each next term in the sequence, you're always getting closer and closer and closer to a particular value. Limit, right? So that's limit. So if the limit as n approaches, gets very large, of a of n exists, or that limit equals some finite value. Okay? Otherwise, an is divergent. Okay, so let's look at this last one here, Bn. Convergent or divergent? Well, let's start with the first one we had. So 2n minus 1. Convergent or divergent? Divergent. This does not, what happens as you let n get very, very large? What happens to the terms of our sequence? They get equally, not equally, but they likewise get very, very, very large. And it never gets close to a number. It just keeps getting bigger and bigger and bigger. Okay? So what about above here? Cn. So -3, 5/4, -7/9, 9/16. Convergent or divergent? So let's imagine that n was 100. Okay, if n was 100, you'd have 201 over 100 squared. Getting close to anything? Imagine 1,000. 2,001 over 1,000 squared. So what happens when n gets really, really big? How does the numerator get big compared to the denominator? What's that? How does the denominator get big compared to how the numerator gets big? Yeah, the denominator gets big at a square, right? So it gets big much, much faster than the denominator gets big. So yeah, so this is going to converge to 0. The limit.
Did you say 2001 on the top?
Mm-hmm. For n equals 1,000.
Oh, okay.
Yeah, 2,001 over 1,000 squared. But just in your calculator, put in 2,000,001, so let's let n equal 1,000,000. Put in 2,000,001 divided by 1,000,000 squared. And see what you get. Right, so the denominator is going to have, 6 more places, right? It's going to be like 1,000,000 times bigger than the numerator. So 2,000,001 over 1,000,000 squared. Did you get something really close to 0? And that's just, the numbers are going to keep getting closer and closer to 0 as n gets bigger. Okay? What about Bn? Convergent or divergent? Does the limit as n gets very large exist? do our values get closer and closer and closer to a finite value? No, they just keep bouncing back and forth. So the limit does not exist. Divergent. Okay, so this feels a lot like functions. So how is a sequence the same as a function? How is a sequence different than a function? What would be the corresponding function f of x to 1 over an over 1 over n squared? So what would be the function corresponding to that? 1 over x squared, right? Okay, so how are these alike and how are these different? So how are they alike and how are they different? What's that? Okay.
Some output resulted of input, like
This is how they're same or different.
that's how they're the same.
Their input-output relationships. That's what you're saying?
Yeah.
Okay. And so for a given input, say 4, do we get the same output in both of these? Yeah. So if you so f of 4 is the same as a4, right? So f of say c equals a of c. Right? F of 4 is 1/16 equals a4. What else is the same about them?
They have similar limits.
Right, good. So as n limit as gets very large, what does that equal?
0.
Definitely 0. And what about the limit as x gets very large of f of x?
Yes, 0 too.
Yeah. So they're going to have the same values for their terms. And then, so therefore, the limit as n gets very large or x gets very large is going to be the same. Okay? What's different about the sequence and the function?
Instead of having a n, it has f of x.
Okay, so I'm talking about in principle, not just symbols, right? So that's just how the symbols are different. But in principle, what's different about the sequence versus the function? Yeah.
A function can be contiguous.
Okay.
And then a sequence has discrete values. It's a list.
Right. So it's like the possible inputs, right? So what's in play here for n values?
Like ordinal numbers, counting them.
Yeah, 1, 2, 3, 4, etc. Whereas over here, x is a member of x can be any real number. So if we're graphing this, basically the graph kind of tells a story here. If we're graphing it, we get 1, 1, 2, 1/4, 3, 1/9, 4, 1/16, etc. And if we're graphing this one, Yeah, we get all the same output values for those, but then we have x could be any real number, so it's continuous on the real number, except for 0, right? And also, x could be negative, right, with the function. So what's different is that you can put any real number into that function except 0, and then for here with the sequence, you would only consider n to be 1, 2, 3, 4, 5, and just get these discrete points. Yeah.
What about mapping? Like you can map multiple x's to the same y, but then with the sequence, can you get one to many?
No.
No. So
For a
that's
given value of n, so for A6, it's 136. That's the only.
so that's a similarity. They both need one to many is okay, but many to one is not. Or other way around. Multiple x's can map the same y, but not the other way around.
No, because like this one. So here, for a given y, there's 2 x's. That would never happen with a sequence. No, that could happen with a sequence too. Yeah, because if it wasn't, this one's always decreasing. But if it moved up, if it changed, it moved up and down. Yeah, you could have that too.
So that could be a possibility, but we couldn't get 2 y's from one x or one n.
Right. Yeah. Yeah. Yes. That's going back to this. That f of c is a of c.
Okay.
Yeah. So.
You still looking at differences?
I think. Yeah. I think we. Is there? You have another one?
No.
No. Yeah. Well, I thought you were arguing something of the same about them.
Yeah.
Yeah. Okay.
I'm just exploring.
Okay, so the graph kind of tells it, right? And then here's the key thing about all this: that the limits as n gets big are the same, or x gets big. So they're heading to the same y, quote unquote, y value or output value if they converge. Okay, if it converges. So then the limit of the function is the same as the limit of the sequence if it exists. Okay, so to find the limit of a sequence, you can find the limit of the corresponding function. So that's kind of the big pull away here. Okay, so let's look at some important types of sequences. So this is when you see a lot. 1 over n to the r. So for example, 1 over n cubed, 1 over n to the 1/2, 1 over n to the 0.8, 1 over n. So these are all examples of 1 over n to the r. So when does that converge? 1 over n to the r converges if what?
R is 2 or greater. 1 or greater.
Try again.
And when R is 2 or greater.
Okay, still not right.
R is greater than 0.
Yep, if r is greater than 0. Because even this, even 1 over n to the 1/2 will converge. 1 over n to the 1/2.
What do we mean with the conversion?
Okay, so convergent sequence is when the limit exists.
Oh, okay.
That's what we just said before you came in.
Sorry.
So this will converge if r is greater than 0. and converges to 0. So the limit as n goes to infinity of 1 over n to the r equals 0 if r is greater than 0. Okay, and so then, what about this? So this is this form. So number 1. Number 2, p to the n. All right, so for example, p squared, p to the 1/2, p to the 0.1, p to the negative 3/4, p to the negative 4. No, what am I saying? These are totally wrong examples. N is the changing thing. Sorry. This doesn't make any sense. Okay, we'll try again. Here we go. 1/2 to the n. 3 to the n. Negative 3/4 to the n. 1 to the n. Negative pi to the n. Okay, so convergent or divergent? So with each next term of the sequence, we multiply by that base one more time, right? So you're gonna notice 1/2, then 1/2 squared, then 1/2 cubed, then 1/2 to the 4th, 1/2 to the 5th, etc. 3 squared, 3 cubed, 3/4, 3 to the 5th. So when do you suppose this converges?
What about when p is 0 or 1?
What's that?
What about when p is 0?
Sure. 0. And I got 1 here. Totally valid. But for what values, so we're asking now, so for what values of p would this converge? What do you think?
That was my guess.
Oh, only 0 and 1, you're saying?
I'm thinking those will qualify.
So can we, is there any others?
Your tone suggests probably.
Greater than -1, less than 1.
What's that?
Greater than -1, less than 1.
Okay, so between -1 and 1. So like this one here, converge? 1/2, 1/2 squared, 1/2 cubed, 1/2 to the 4th, 1/2 to the 5th. Keep multiplying by 1/2. Convergent? Yeah, that's gonna converge to 0. What about this one? Negative 3/4. So what do you with each next term of the sequence, you take negative 3/4 of what you had in the previous term, right?
Yeah.
You keep multiply by one more negative 3/4.
That's cool.
Converge or not?
Yeah.
2?
0.
0, right? If you keep taking 0.75 of what you had before and take that forever, that will converge to 0. Now that one will alternate, right? So for positive or even n, you'll have a positive term. For odd n, you'll have a negative term. So it'll alternate, but it keeps closer and closer to 0 as it alternates. It's just going to jump back and forth and get closer and closer to 0.
Nice.
All right. So yes, you nailed it. When it's 0 when p is between -1 and 1. What about outside of those? So 3 to the n. Converge or diverge? Certainly diverge. You keep multiplying by 3. Each one is 3 times the one before. Definitely divergent. Is there anything else that could converge? There is one more case.
What about I?
No, too hard. You're making it too hard. So you keep multiplying by something over and over again. It stays the same value. What is that? 1, right? So it will be 1 when p equals 1. Yeah. Just 1 times 1. You know, every time you just keep multiplying by 1. Well, your sequence is just going to be an infinite list of 1s. That converges to 1.
What happened in the I case?
What's that?
What happened in the I case?
It's just going to jump around between 1, 0, and -1.
Well,
Oh, no. No, it's going to jump around between I, negative I, 1, and -1. You're just going to get those 4 and it's going to keep going, right?
yeah, that makes sense. And then there are rules,
This
right?
could be,
depending
like-
on the end, you can just think if it's odd, even.
Okay, so this is 1 over n to the r. That sequence converges to 0 as long as r is greater than 0. And then you have p to the n. Has 2 cases where it converges. Let's put brackets around here. Two possible cases when it converges. 0 if p is between -1 and 1, and it will converge to 1 if p equals 1, because you just have an infinite list of 1s. Okay, so have you try some? So basically, determining if sequence is convergent is a matter of intuition, common sense, possibly these rules. Okay, maybe just generating the first 5, 6 terms of the list and observing. So you just kind of have to. It's kind of different little approaches that you make on each one. So it's just kind of a matter of experience. So let's practice here. So how can we, convergent or divergent for number 1?
Convergent,
How do you know it's convergent?
because whatever examples can be given.
That's all.
Okay. So could we rewrite this as? Anyone rewrite this as? 1/5 to the n. Did you do that?
Yeah, we can.
We can. Did you?
No idea.
And so, and then why does that help?
Gives you a sense that one. P is less than 1.
What's that?
P is less than
Yeah. So this is the p. This is that p sequence, right? P to the n. P to the n, where p is less than 1. So it converges to 0.
Could we also not have seen that this denominator explodes?
What's that?
Couldn't we also just have seen that the denominator explodes and that shrinks the rational?
Yeah. But we also want to just, also recognize these forms.
Definitely.
Okay. What about this one?
Convergent.
How do you know?
It's
Because it's only slightly less than like the numerator is only slightly less than the denominator.
Okay.
By extremely marginal amounts.
Okay.
Well, the degrees are the same, top and bottom. So
Okay.
the limits will be the same top and bottom.
Well, that would also be true if I had a 3 here. The degrees are the same, or the limit's going to be the same top and bottom.
Also, then you compare the coefficients.
Okay.
Of the leading term.
Yeah, so this is like, you think back to rational functions in pre-calculus. What happens when you get very, very large input? And so, yes, you can think of it as a rational function. So we can make this as a function and look at that limit. So remember, the limit is the same as the corresponding function.
You know the limits are the same, do we have to liken it unto a function? Or can we not just take the limit of the sequence itself?
And how are you going to do that? What are you going to do? What are you going to apply to do that?
I meant just like skipping the step of rewriting it in terms of x.
You Logic reverse.
I mean, I guess that's what I'm doing in my head, is this step.
So-
it's helpful to write it.
But I wanted to show you that you can apply something that you've learned before to this to solve this limit.
Right.
And what is that? Because this is really what? Infinity over infinity. Do you remember what we can apply to that?
Oh, L'Hopital. Okay.
Yeah, we can use L'Hopital's rule, and so then it would be the same as the limit
Oh, that's cool.
of 2x over 2x, which is the limit as x goes to infinity of 1, which equals?
You can do 2 over 2.
No, 2x over 2x is 1.
Right, I just meant L'Hopital again if you want to really force it.
No, it's not, because it's not an indeterminate form. L'Hopital's rule is when you have indeterminate form, like 0 over 0 or infinity over infinity.
Don't we still have infinity over infinity?
No, we have 1. 2x over 2x is 1.
Okay.
So what's the limit as x gets really, really big of 1? Yeah, 1 doesn't care about what x does. It's just 1, right? Right? So x's are gone. So x can do whatever it wants. 1 is still 1. Okay, next one. Divergent or convergent? Divergent. Why?
Because the numerator has a degree greater than.
Yeah, so again, you can just think of this as a rational function. If the degree of the numerator is greater than the denominator, it's just going to increase without bound. You could do L'Hopital's rule again. Okay? X squared over x plus 1 is infinity over infinity. And then you get the limit of 2x. So by L'Hopital's rule, you'd have the limit of 2x as x gets really big, which gets really big, so it's divergent. So yeah, you can just reason this as a rational function, or you can use L'Hopital's rule. Same with this. Reason as a rational function, and since they have the same degree, you look at the ratio of the coefficients, or use L'Hopital's rule. This one's p. What about this? Okay. I'm always much more interested in the reasoning than the answer, right? So what's...
So cosine is a periodic function.
Okay.
So
everything that would be cosine would be divergent?
no.
Okay. So we got to make sure. So
Well, this part's still on, but when you plug in 1, it's
Okay.
just going to be alternate between 0 and 1.
0 and 1. So when n is 1,
You get 0.
0.
yeah, I guess if the angle relates to the period, it would be convergent, right? So then it would just bounce around to the same value.
Yeah. So it depends on what cosine function you have.
Yeah.
But this particular one, you get 0, and then your next term is
Negative 1.
-1. Then
Negative 1.
Then 0.
+1.
Positive 1.
This is all for this one up here. Okay. And so this is just going to keep bouncing around.
Yeah, like a clock.
Yep. Etc. Divergent.
So what is the name for that subset of the sequence, like the repeating set of terms?
I don't know if there's a name.
Is that like,
These are all valid terms. 0 is a valid term.
right? But what I'm saying is I'm intuiting that it's going to repeat 4. So is that like helpful in some sense?
I don't. Yeah, so it's cyclic. You know,
Yeah.
it's cyclic. Okay, what about this one?
Divergent.
And how do you know?
Because if you that is also pi over 3 to the n.
Good. And what about that?
And that is p, so p is greater than 1.
Right. You've got a p-value. Your base is outside of that -1 to 1 range. So if pi over 3 is slightly greater than 1, so you're going to keep multiplying with something bigger than 1, it's just going to grow indefinitely, right? Okay, questions on these examples?
B is convergent, right?
Which one?
When it's 1, it's convergent.
Yeah, if the limit exists, that's the meaning of convergent, if the limit exists. Other questions? Here's all the answers I did before. There's another set of problems there. Okay, so here's one. Three to the n plus 2 or 5 to the n. So what we're always looking for is to see if what tools do we have that apply to this. So, but we might have to adjust. We might have to manipulate this to make it apply to the tools that we have. So what does 3 to the n plus 2 equal?
3 to the n times 3 to the 2.
Okay. Yeah, so this is n plus 2 threes multiplied together, right? This is saying how many times do we multiply 3 together? N plus 2 times. So isn't that the same as multiplying 3 n times together? And then
3 squared.
how many more times?
3 to the 2.
2 more times, right? That should make sense. Multiplying 3 some number of times together is n plus 2 times means you can multiply 3 together n times and then 2 more 3's. Okay, and that'd be over 5 to the n. And why does that help?
So we can take the 3 over 2 out.
You can take the what?
The 3 over 2. The 3 squared out. Or 6 or 9.
Okay, and then
And
2 over 5
And you collect the exponent.
you got 3 over 5 to the n.
convergent or divergent? Why?
Divergent. P to the n. P plus
P is
less than
less than 1. So that thing goes to
2,
0. And then, so this whole thing goes to 9.
No, it goes to 0.
Goes to 0. 9 times 0 is 0. Convergent. P is less than 1. And 9 times something that converges to 0 is still converges to 0, it just does it a little more slowly.
That makes sense because it's broken on the top.
Okay, here's a cool one. This.
It's cosine squared.
Cosine squared over 2 to the n. Cosine squared over 2 to the n. Yeah, so n. What do we know about cosine? Watch this. What do we know about cosine? Okay. And it never gets bigger than what?
Amplitude is 1, right?
It never gets bigger than what value? Please know this. 1. And always stays greater than or equal to. Okay, so then what about cosine squared?
So it's always 1 or less.
Still from
Negative 1 to 1?
No, just forget the left.
Well, then that means cosine squared could be negative 3, negative 8, negative 10.
Just always always less than or equal to. Oh, Squeeze
No,
Theorem?
it's still,
It's bounded by 0.
it'd be the squeeze.
0, we're squaring it, okay? We're squaring it. So cosine, when you square it, you get a positive value. So it's still, biggest it could be is 1, but now it'll always be positive, or 0. So that will be between 0 and 1. Okay, so then what we can do is we could divide all these by 2 to the n. So we still get 0 less than or equal to cosine squared n over 2 to the n less than or equal to 1 over 2 to the n. So now we've got our sequence, and we've got our sequence. It's always 0 or greater, because that thing's always positive, but it's always less than or equal to 1 over 2 to the n. And what do we know about that?
It goes to 0.
Yeah, that's 1/2 to the n, because p is 1/2. And that is just 0.
Yeah, so it's 0.
So what about this thing? If it's always between 0 and something that approaches 0, then what must it do? It must go to 0, converges to 0 as well. And this is what's called the Squeeze Theorem. We have a sequence, and its terms of a sequence are always between 2 other sequences that converge to the same thing. So that thing must converge to the same thing because it stays between them. Okay, questions on that? Maybe let's go faster. What was it? Sorry, I forgot to bring my printouts. I had all this out for my notes. Okay, try that. You guys try. So this just involves one thing we haven't seen yet, but then from there it's
Does this involve the value of
a little bit. So once you get the first step, this is pretty easy. Not too much different. What is the first step? Did you get the first step, Kieran?
I broke it up into two functions.
So what'd you get? Tell me.
E to the n over 4 to the n minus 1/2 times 6 to the n over 4 to the n.
Okay, so good start. And then what?
And then the first term is just e to the 4 quantity p.
E over 4 to the n. Wait, what'd you say?
Yeah.
Convergent or divergent? This one. E is 2.8.
Convergent.
So that's convergent, all right? What about this over here? 1/2 what?
6 over 4, quantity 3.
Convergent? Divergent? Divergent, right? You keep multiplying, you keep taking 50% greater than what you had before. You keep multiplying by 1.5. So what wins? Okay, sequence going to 0 or sequence going to negative infinity?
Can you explain 1.5 out real quick?
What's that?
Can you explain 1.5 out real quick?
Sure. A times B over C is equal to A times B over C.
Okay.
Does that get it?
Yeah.
But the key is grouping the 6 and the 4 together and you get the 3/2. So this thing is going to, the whole thing then converges to 0. Right? No. That goes to 0. And that goes to, it's really big. And so now it's going to be 0 minus something that's really, really big.
So negative infinity.
Yeah, divergent.
What if you had some other quantity that first to the left side of this factor sign that went to
Positive infinity. Then it's indeterminate form. It's kind of like infinity over infinity. So infinity minus infinity, that could be infinity, that could be 0, that could be a finite number. So you have to do more. You have to work on it more. But that's infinity minus infinity is indeterminate. That's different cases. But this does not. That thing goes to 0, that thing goes to infinity, therefore negative. Okay, factorials. So you know what n factorial is? What does n factorial mean? It doesn't mean n. What does it mean? Add all the numbers up to n.
The product of all.
Yes. Add or product?
N product. N times n minus 1 times n minus 2 times n minus 3.
Product.
to 0.
Okay, so some of you are saying add things, some of you are saying multiply things.
No, wait.
Multiply. Multiply. Yes. N times n minus
You take, yeah, it's,
It's a sum.
Sum.
No, it's
Sum.
look at that.
Sum product.
That is it.
okay, so it's, you start with a number, and then you multiply by one less, and then one less than that, and then all the way down, and then you stop at 1. That's n factorial. So write out what is 4 factorial equal? What's that? What's that?
We're gonna just use the calculator.
24. No, you have to know what it means. You're not, what is it? Matthew?
It's 4 times 3 times 2 times 1, which equals to 24.
That's it, right? And I love that he said it's 4 times 3 times 2 times 1. It has a meaning, right? it not only equals a value, but it has a meaning. And that meaning is 4 times 3 times 2 times 1. 2 factorial? 2. 2 times 1. Okay, how about this? 11 factorial over 9 factorial. Is it 2 factorial?
It's 11 times 10.
Everyone's work on it. 2 factorial. Everyone work on it.
Which one are we doing?
11 factorial over 9 factorial.
Over 9. It's going to be a big number over 11.
It's not that. Yeah, it's not that. It's not that. Just write it out so it cancels. Yeah, it's
Right? So, yeah.
So just be
It's just the difference of the.
Yeah.
Yeah, I see.
So it wouldn't be 2 factorial. It'd be like
Write it out.
whatever.
Whatever.
What is the name for the term that designates the factorial? Like, what is the name for that?
Yeah. You like take, how would you take the
So,
No, that's the
Uh, there might be the arguments.
argument.
Argument.
Yeah.
All right, so think about what this means. You got 11 times 10 times 9 times 8 times 7, all the way down to 1. And then this is 9 times 8 times 7 times 6, etc., down to 1. So what do you notice about 11 factorial?
It's composed of some leading terms and 9 factorial.
Yeah, it's composed of every factorial that's less than 11. You see that? Every factorial less than 11 factorial is part of 11 factorial.
Yeah.
So 9 times 8 down to 1 is part of that product. That's 11 factorial. So if you divide by 9 factorial, those go away. So this and this equals to 1. So you're left with just 11 times 10. Is that 2 factorial?
No, it's not.
Not even close, right? Students throughout the ages have probably said it's 2 factorial, but it's 110.
Are we going to do combinatorics?
Okay, so here we go. How about this sequence? 2n minus 1 factorial over 2n plus 1 factorial. Convergent or divergent? See if you can figure it out. I'm going to look on it. And here's a harder one. What's that? Oh, that's the wrong number from some book.
We're doing both.
For sure the first one. Here's where your calculator is going to do any good. You've got to make sense of these factorials. Natalia, did you make any progress on the first one? You plugged in a number. Can we write out what these are without plugging in any numbers? What would 2n minus 1 factorial be? We write out what that equals?
Well, it's harder to do. You just expand the bottom.
2n minus 1 times 2n minus 1 minus
Which is what? Yeah, which is what? 2n minus 1 times 2n minus 1 minus 1, which is?
2n minus 2.
2n minus 2. Then times
2n minus 3.
all the way to?
2n minus n.
All the way to?
2n minus infinity.
No. All the factorial means start with that number and keep multiplying down until 3 times 2 times 1. All factorials multiply down to 3 times 2 times 1.
And then do the same for the bottom.
Same for the bottom. Do the same thing for the bottom.
We get 1 over the first 2 terms.
What's that?
Isn't it just 1 over the first 2 terms?
Factors.
Factors.
Terms are added and subtracted.
Okay.
Factors are multiplied.
Got it. 1 over the first 2 factors.
Yeah, because now you have 2n plus 1, and what's the next one?
2n plus 2.
No, down by 1. You go down by 1. You reduce the number. You don't go up.
Like it's 7, 6, 5, 4, 3, 2.
Right. 11, 10, 9, 8.
Oh, 2n.
2n.
2n plus 1 minus 1.
And then, what comes next? 2n minus 1 factorial. Right? Or you can write them out again. If you want to write them out again, that's fine. But 2n minus 1 factorial is part of 2n plus 1 factorial. It's just that you have those first 2 terms. Okay? So then what does this sequence equal? It's the same thing as 1 over
2n plus 1 times 2n.
What about this? So this is the same sequence as that.
So our convergence is
4n squared plus 2n if you want. Convergent or divergent? Convergent. So this is like 1 over n to the r, right? As long as r is greater than 0, and here's r, it's 2, and then it's also 1 here. So that converges to 0. Because your denominator is 4n squared plus 2n. Alright, we won't do this last one. That'll be good.
How do you expand the
If you want to stick around, I'll do this last one, but we'll do this next.
Cool.
I don't understand.
What's that?
How do you get to 1 if you're reducing 1 to a minus 3 that's 4? You're just going to go forever.
Factorial. What does factorial mean? What does factorial mean? You start with that number, then you multiply by 1 less. Then you multiply by 1 less until what?
Okay. Until you reach 1.
Until you reach 1, no matter what number you're doing. Always multiplies down to the last one you multiply by 9. What's that?
So you have 2n, so you're multiplying your number by 2. Then you're multiplying your number by 2 to 2. So you're dropping your number by 1 every time.
track 1? Multiply. Track 1. Multiply.
Okay, so this one, let's expand out the top. So what does negative 3 to the n mean? What does that mean?
Negative 3 everything until negative 3.
No, that's not what it means.
Nope.
Negative 3 to the power n means what? What does that represent?
Negative 3 times itself n times.
1 over
just asking about negative 3 to the n.
Negative 3 multiplied by itself n times.
Negative 3 multiplied by itself n times. So there's n factors of negative 3. Okay? And we got n of those. How many factors are there in the bottom? N factorial. How many factors does n factorial have? Okay, I got 1, I got n, and I got infinite.
No, there's n. Right, because 7 factorial would be 7 separate factors.
N factors. N, what's the next one?
Minus 1, n minus 1,
This one,
n minus
2, all the way to
n minus
3, 2, and 1. So,
The 3 times 2 times 1.
Well, that's arbitrary.
factorial. Factorial. It's always, you always multiply down to 1. You do a factorial.
Oh.
Right? So whenever you do a factorial, you start at that number, that argument, you subtract 1, you subtract another, and you keep multiplying. If it's factorial, it's always, by definition, factorial always then down to 1. Okay? Alright, so this is kind of convenient because this gives us n terms, and this gives us n terms, so we can group them together. So this right here is, so let's just, so all of these are going to be a number less than 1. Do you see that? Because this would be negative 3 over 4, and then negative 3 over 5, and then negative 3 over 6, and negative 3 over 7. So all of these will be fractions less than 1, and what's this? All here, this is going to be negative 27 over 6. Those last 3, you group up the last 3 factors of each one. You can group that into negative 27 and 6.
Why did you choose the last 3 factors?
Because these are all greater. This is 1 or greater.
Oh.
That this one is negative 3 over 4 is less than 1. Negative 3 over 5 less than 1. So all of these fractions are less than 1. So really, this whole thing is less than negative 3 over n times negative 27 over 6. Because all of these multiplied together would be less than 1. You see that? Would you buy that? These are all less than 1. These are all magnitude less than 1. You keep multiplying by something less than 1, it's going to be smaller. So I'm going to hold on to that first one, and I'm going to hold on to the negative 27/6. And since these are all magnitude less than 1, ours is going to be less than negative 3 over n times negative 26 over 6. And what does that do? As n gets really, really big.
Approaches negative.
No. No.
That was the question?
What does this do as n gets really big? 0, right? 0. It's in the denominator. N is in the denominator. What we have is less than that, because it also has a bunch of terms that are all less than 1. So you're going to take whatever that is, and you're going to multiply it by all these fractions that are less than 1, so you're going to make it even smaller. So it's like squeeze. It's like this thing gets squeezed between this and 0. Because this is going to be less, because it has all these terms that are less than 1.
So those terms less than 1 multiply together to eventually come to 0. With negative 3 over, say, negative over n minus 1. N minus 1 is going to be less than n, which is, and n might be positive, so n minus 1 might be 0 or negative 1.
You lost me.
I lost myself.
All of these fractions are less than 1. What happens when you multiply something that's times something less than 1?
It gets small.
It gets smaller. Okay? So if I just took this first one times the negative 27/6, then what we have would have to be less than that because you have all these things that are less than 1. What does this do? This goes to 0. So this is always less than it, so it must go to 0. So this is like the squeeze theorem. So it's like so call ours an. So 0 is less than an is less than 3 over n times 27/6, which goes to 0. So ours must go to 0 too. Now this is yeah. Is that better? Does that make sense? It's amazing. Yes, it is.
It's insane.
Okay, just check Blackboard for homework. Yeah, homework.
It's so simple.
So
hard. Like, yeah, so logic.